Hello, everyone. My name is Xuchen Li, and I come from Institute of Automation, Chinese Academy of Sciences. It's a great honor to participate in the third CVPR workshop on Vision Datasets Understanding. I'm very glad to share with you our work titled Diverse Text Generation for Visual Language Tracking based on LLM. Human beings acquire approximately 83% of their information through vision, which makes us vision creatures. Within our dynamic vision systems, the ability to track objects is fundamental and crucial, modeling our dynamic vision capabilities. In Vision Track area, visual language tracking is defined as the process of only providing the initial precision and natural language descriptions of a moving object, and then continuously located it within a video sequence. However, most VLT benchmarks are annotated at a single granularity level and lack a coherent symmetric framework that could provide scientific guidance for the development of tracking algorithms. The current state of VLT benchmark is characterized by the consideration of studies from various perspectives, yet they face several limitations. The first limitation is that symmetric annotations in the OTB dataset primarily describe the initial frame of the tracking sequence. This can potentially misguide the algorithm, as it may not capture the dynamic changes in the object's appearance behavior throughout the video sequence. The second limitation is found in the MGIT dataset, where the complexity of the provided text annotations does not facilitate algorithm learning. The descriptions may not align well with the learning capability of tracking algorithms, which could impede the development of the more robust and adaptive tracking systems. Our primary aim is to harness the power of LLM to furnish VLT with multi-granularity symmetric information. By adopting an approach that is both effective and diverse, we seek to enable a fine-grained evaluation of tracking performances. This innovation application of LLM promises to offer a deeper understanding of dynamic within VLT datasets. We introduced a novel method for generating diverse text based on LLM, termed DTLM VLT, recognizing the crucial role that diverse text plays in the evolution of VLT. Our approach integrates the LLM into the text generation process. This integration is designed to create a rich and varied environment that can advance VLT research. By leveraging the generative capabilities of LLM, we aim to produce a wide array of text descriptions that capture the nature of viewing sets. This diversity in text representation is expected to enhance the robustness of tracking algorithms, enable them to better handle the complexity process in real-world video sequence. In our pursuit of enhancing VLT, we present a multi-granularity diverse symmetric generation strategy that applies text generation techniques across various levels of granularity. We initiated our strategy by generating text annotations for the first frame of each video sequence, adhering to established method of OTB and TLL2K, anticipating challenge scenarios where tracking algorithm might struggle due to absence of an effective memory system. We introduced a dense text generation approach. In this strategy, we simulate a continuous supply of relevant text at the rate of 25 fps, equal to the provision of new text every 4 seconds or every 100 frames. What's more, when the bounding box already processes and provides a comprehensive account of the temporary and spatial dynamics of the object, our strategy advocates for concise text descriptions. These texts are crafted to deliver essential symmetric details. Conversely, in instances where the bounding box does not convey enough information for the tracker to learn effectively, our strategy calls for more detailed text descriptions. Our approach to deliver text generation for BLT is underscored by a robust dataset that reflects the depth and varieties of our symmetric distribution. In vocabulary richness, with 1.9 million words, our generation process taps into a vast pool of linguistic resources. For unique expressions, we have generated 14.8 thousand no-repetitive words to guarantee that our text descriptions offer novel and varied symmetric contents. For the crucial first frame of each video sequence, we have crafted 7,238 initial descriptions. To support the trackers throughout the video sequence, we have generated 128.4 thousand dense descriptions. This figure not only demonstrates the scale of our efforts, but also reflects our commitment to enrich VLT with a diverse and symmetrically rich text generation strategy. We have developed a comprehensive evaluation framework to assess the performances of our VLT approach. In Mechanism A, we utilize the official weight files as provided, without altering any parameters. We conduct a directly test of tracking performance to establish a baseline and to evaluate the inherent capabilities of existing system. For Mechanism B, building upon the initial assessment, we continue training the model for an additional 50 outputs. A key aspect of this mechanism is the substantial of the visual text within alternative text generated by our DTLM VLT method during the training process. This allows us to analyze the impact of diverse metric informations on the learning and adaptation of the tracking algorithm. Our experimental findings underscore the importance of line text generation within the unique demands of different tracking tasks. For short-term tracking, our analysis indicates that dense consigned text yields the most significant performance gain. The precision of this text enables the tracking algorithm to quickly act upon the information, which is crucial in scenarios where rapid updates are necessary. In contrast, dense detailed text are found to be more advantageous for long-term tracking and global instant tracking tasks. The additional content provided by the text supports the algorithm ability to maintain a robust understanding of the tracking target over extended period and invalid conditions. Our analysis also points to the need of adjustments and improvements in the text processing method and the multimodal alignment capabilities. The tracking algorithms must be adapted at handling diverse text inputs and integrating them effectively with visual data to enhance overall tracking performances. The insight from our experimental analysis guide the refinement of our text generation strategy and the optimizer of the tracking algorithms. By recognizing the task-specific requirements and adapting our approaches accordingly, we aim to develop a more effective VLT system. At the same time, I would like to introduce to you our series of works in the field of SOT and VLT, represented by the platforms VideoCube, Thoughtverse, and GOT10K. We have been published in top international journals and conferences, and the related platforms have received wide international attention. We welcome everyone to follow our work. I'd like to extend my thanks to each and every one of you for your attention.